We are finding the area of a circle. The area of a circle is the product of pi and the square of the radius r. In the other video that is on Schoology, you will find out why this is the case. However, I'm just trying to show you how to use this formula in this video here. So, to find the area of the circle, we use area equals pi r squared. In order to do that, the first thing you ought to be doing is you ought to be writing down the formula A equals pi r squared. Next, you should substitute 3.14 in for pi. Next, you should be substituting the number for the radius in for r. So in this case, it's 14 feet. So we're going to go 14 squared. This squaring bit right here, this 2, means that we're going to go 14 times 14. So on my next line, I have 3.14 times 14 times 14 is 196. Then, for the last part, we're going to multiply 196 by 3.14. Which gives us 615.44, and this would be in feet squared. You should be including your units. One more time, you write out your formula. You substitute pi for, 3.14 for pi. You substitute the value of r in for r, so the radius given in the diagram. You multiply that by itself because that's what the square means. You then multiply 3.14 by 196 and you get your answer, and then you put down your units, and your units are square units because it's area. Let's try the next one. In this next problem, we again have a circle, but this time we have a diameter. So we're going to add a step in front of the problem. This time around, we're going to change our diameter into a radius. So a radius is the diameter cut in half. So I write out the little formula here so that I know what I'm doing, and then I go, all right, well, that's radius equals 30 divided by 2, so the radius is 15 meters. Now, again, I do what I did last time. Area equals pi r squared. I write down my formula. I replace pi with 3.14. I replace r with the radius I just found, which is 15. I write down the square. This square means that we're going to do 15 times 15. So we go area equals 3.14. 15 times 15 is 225. We multiply 3.14 by 225. And that yields 706.5, and that's meters squared. Walking through this one more time. I was given a diameter, so I wrote down my formula for radius equals diameter divided by 2. I substituted in that diameter and got the radius. Then, after that, I wrote down my formula for area. I substituted pi with 3.14. I substituted the radius with 15. I had this square. The square means that 15 times 15, because we multiply the number by itself. Then 15 times 15 is 225. And we multiplied 225 by 3.14, giving us 706.5. So the last of these. Third example, this is a semicircle. A semicircle is half of a semicircle. So if we're looking at our formula is for a whole circle. But if we want a semicircle, all we need to do is take this little formula and divide by 2. So we're going to rewrite our formula here. We're going to go area equals pi r squared over 2. But before I can use this, I stop and I realize I'm given a diameter. So since I'm given a diameter, I go back to r equals d over 2 because I need the radius. I can't put a diameter into this formula. So radius is 16 over 2. And so radius is 8. So again, I've written down my formula. So we go area equals, we replace pi with 3.14. I replace r with 8, and then I square. One more time. That square means we do 8 times 8. So we have a equals 3.14 times 64. So our area then is 3.14 times 64, which gives us 200.96. And that's centimeters squared. Okay. Just wanted to make sure I put units on the last one. And so when we finish this, we go, let's take a look back through one more time. We were given a diameter, so we had to find the radius. So we used our formula, we substituted in the diameter, we got our radius. Then we use our formula for a semicircle, which is pi r squared cut in half. We substitute pi in as substitute 3.14 in for pi. We substitute the 8 in for the radius. We square that 8, which means multiply 8 by itself. We get 64. We then multiply 3.14 by 64, giving us 200.96. We make sure that our units are on it and they are squared. This is how we find the area of a semicircle. So again, we found the area of a circle with a diameter, and we also found the area of a circle given a radius. On the problems that you're doing today, there is one story problem, and it gives you a circumference. And it wants you to take the circumference and travel over to get to the area. You can do this if you stop and look at your formulas. You know that you've got formulas for circumference like pi d and 2 pi r. And you know for area is strictly pi r squared. If you actually use your formulas, substitute values into one of these, you can get a value that you're missing to put in over here. Likewise, if you were ever given your area, you could put your area in here and you could solve for r. Now that would be a little trickier because you're going to have to know how to use a square root, which I'm not sure how many of you do. I don't think you're going to be asked one of those questions, but if you did get ever asked one of those questions, you hopefully know things like the following. Your perfect squares being like 2 squared is 4, 3 squared is 9, and so on and so forth. But if you're using these formulas, which I'm noticing we were having a lack of doing that yesterday, if you're using these formulas, you can stop, analyze the formula, think about what the formula says, and then come up with an answer or a method for how to do the answer. Because the bright side of these formulas is, even if you're looking for d, if you're looking for r, if you're looking for r squared, more or less, you're just dividing two numbers in order to get there. But instead of just going, oh look, I'm dividing out of the blue, if you use your formula, you're following a system. And in mathematics, we want to follow a system of maneuvers so that way we can all together know how we're getting an answer.